All right. Number 17 says, use the fundamental theorem of calculus part 1 to evaluate the integral. Let's first go over what is the fundamental theorem of calculus part 1. Suppose we have g of x equals to the integral of going from a to some value. We're going to call this g of x. No, I don't call it g of x. Let's call it h of x. Of f of t dt. It's kind of similar to like what we've seen in question number 16. The h of x was just x to the first power. Then, if we take the derivative of both sides of this function, the derivative of g of x is going to be g prime of x. G prime of x will be equal to, now, the integral and the derivative. They're inverses of each other, so they should cancel out, which they do, leaving you with the inside function with just some modifications. Now, I want to give you the shortcut version of it. That is going to equal to f of h of x, and that's going to be multiplied with the derivative of h of x. Now, we did kind of the longer version in class. Well, we're going to do it in class, I should say, since I'm making a video on Friday and classes on Monday. But yes, this is essentially what it is. You may see this version of g prime of x equals to f of x, but that's more of a shortcut version. That's more of a simpler version. The one that I'm giving you is one that you need to apply. Now, we have the integral from 0 to x of 1 over t squared over e to the t dt. Basically, to utilize that, we're going to take the derivative of this integral. And so, the answer to this question will be, if you follow the format, I'm going to plug in my x into every variable of t. So that's going to be 1 plus x squared divided by e to the power of x. Then I must multiply by the derivative. Let's put that in red. Multiply that by the derivative of this term here, which is x. The derivative of x is just 1. So that's going to be 1 plus x squared over e to the x times 1, which is just 1 plus x squared over e to the x. That one's fairly simple. We're going to do the same thing for the next one. The integral the integral from 2x to 5x of cosine of t dt. And we want to use the fundamental theorem of calculus part 1. So we're going to take the derivative of this integral. This one here is a little bit more tricky. And that's because I have variables for my lower limit and my upper limit on my integral sign. I need to make some modifications. Well, just like we see here in question 16, when I scroll up, and I'm going to scroll over here, you can break the integral up based on the rule that I provided in video for number 16. I'm going to use the same theorem. I'm going to say that there's some unknown number c that is between 5x and 2x for me to break up my integral. So we're going to write this as the derivative. And I'm going to put this in a bracket. That is going to be the integral from 2x to some constant c. And that is going to be cosine of t dt plus the integral from some value c to 5x of cosine of t dt, such that c is between 2x and 5x. On your exam, if you do have that question on your exam, you don't have to explain that part. I'm just going to know what you're talking about. I'm just explaining to you why it's important to say that. Another property of integrals that I will show you in class as well is known as the limit reverse prosody. Property. What is prosody? Property. Suppose you have the integral from a to b, f of x dx. We can reverse the order of our limits. We can flip the integral sign. If we reverse the order of our limits, that is going to be the integral from b to a of f of x dx. But because I flip the integral, that is going to make it negative. And the reason why I need it to be negative is because this first part right here. We need the function in the top, the upper limit of the integral, not in the lower limit of the integral. So what I'm going to do is I'm going to take my derivative and I'm going to flip the integral sign for the first one. So that's now going from c to 2x cosine of t dt. I leave the second one the same. The derivative of the integral of cosine of t dt, limits going from c to 5x. But because I flipped the integral for the first one, we must make that negative. And now we can follow the formats. So that's going to be negative cosine. And instead of having t, you're going to put your 2x inside here. But remember, you must then multiply by the function in the upper limit. And the upper limit is 2x. So that's going to be times the derivative of 2x plus cosine of 5x. And then we have to multiply by the derivative of 5x. And to wrap that up, the derivative of 2x is just 2. So that's going to be 2 cosine of 2x. Don't forget your negative. Plus the derivative of 5x is 5. So 5 cosine, put it in red actually. 5 cosine of 5x. And that is it to this question. All right, guys, that's it for the video. Hopefully you enjoyed it, liked it, you understood it, and I'll catch you in the next one. Take care.